Good morning and welcome to this training session on BricsCAD BIM. Today I will show you some of the basic modeling techniques and basically show you or explain to you how you can model buildings. Either you can model them manually or you can import from somewhere and edit them further. It's basically all up to you. So let's get started. When we open this overall .dwg file here, we can see already that there's already quite some geometry there. Actually, in this case, these are all XREFs. So for those of you that don't know what an XREF is short for external reference. And it basically means that another drawing is being referenced inside this drawing. You can see if I hover over one of those objects here, I can see actually this is one external reference. This is one XREF, and this is one XREF. Actually, these XREFs can also be seen in the attachments panel. So the attachment panel can be found here on the right-hand side of your screen. It's a little paperclip icon. If I click it, I will see 3 attachments. Actually, if you don't see this paperclip icon, you can always right-click somewhere in your ribbon and under Panels, go to Attachments and tick this on. So you see here we have 3 XREFs, side, east, and west. This east building is basically just a box model. We will model this later into something more interesting. This is already a bit more advanced, this building, and here that we have the side building. But I'm showing you this site with these XREFs actually to show you that you don't need to model everything from scratch. You can always import geometry and edit this geometry afterwards. For instance, if I go to the import button here and import the 3DM file that is delivered with the starter files, modeling, flowing rail, there should be a 3DM file. You may have to change your file type here. So it's a file that was made with Rhino actually. We can simply import this, and as soon as it's imported, it's automatically converted to DWG, and you can do any kind of operations on it. You can do direct modeling on it. We can add information to it later. So one of the next sessions is going to be about adding BIM data, adding information. You can always do this on imported geometry as well. Let's say, for instance, here I can see this geometry. There are some beams here. Well, actually, they're just solids. They're not beams. But I can do any kind of direct modeling operation on this. I can push-pull this. I can classify this as members or beams. But the important part is to remember is that you can model anything and apply any kind of information to it. So you don't need to predefine everything up front. You can always model everything freely and assign information to it later, or import geometry and enrich the information in there. Whether this imported geometry is from IFC or Rhino or whatever. Okay, so let's start with some basic modeling. For this, actually, before I start, I'm just going to open a new drawing, an empty drawing, and just kind of repeat some of the basic concepts about selection modes. So let's say I have 2 boxes here, or I'll just start with 1 box here. Very important to remember is that there are different selection modes. You can find them here in the quick access toolbar or in the home tab of the ribbon. For now, I'll just turn all of them off. And you will now see if I hover my cursor over this object, this box, it will highlight the entire solid. So the entire solid is highlighted in blue. You can also see here in the quad 3D solid. If I select it, in the properties panel, you will see I have the properties of this entire solid. Now this solid has sub-entities, which are faces, edges, and vertices. If I enable face detection, now if I hover my cursor over this object, I will see that this face is being highlighted. And I also see here in the rollover tips, solid face and some properties of this face. If I select it, I can select multiple faces at once. And same goes for edges. So if I enable edge selection, and now move my cursor over one of the edges of this box, it will also highlight this edge. So it's very important to distinguish these concepts. Especially when modeling, you're going to be switching a lot between selecting faces, edges, and solids. And for the next exercise, it's actually really important that you remember these points. Actually, a personal tip for me, I only use face detection mode when I'm modeling. For the rest, I always have all of my other selection modes off. So if I'm not modeling, I just use this combination of selection modes. If I'm modeling, usually I have it like this. So I have my face detection on and the rest off. And sometimes boundary detection, depending on what I'm doing. Boundary detection is actually kind of a special case. Let's say I have another box here. We draw it like so. If my boundary detection is on, you will see that if I move my cursor over this face, it will not select or highlight the face. It would have been in orange. It's actually highlighting the boundary, so it's really taking the boundary of this shape here. So this can be useful later on. I will explain you some different situations where this might be useful. One final thing about these selection modes, if you hold Control, it will invert the selection mode. So currently I have my selection of faces prioritized, so enabled my selection of faces and disabled my selection of edges, which means if I would not hold Control, I would highlight my faces, not the edges and not the solid. However, if I would hold Control now, it will do the inverse. So now I am highlighting my solid, and if I go to the edge, I'm highlighting my edge. And then I can use this to, let's say, fillet this edge. Okay, so now that we have these basic concepts out of place, I will just open this XREF here. So it's just a simple box, and we will sculpt this into a simple building. To open it, you can either just go to your file explorer and open the DWG file, or you can highlight it and in the quad under Modify, go to Open. Alternatively, you can go to the Attachments panel and right-click and click Open. So now we see that this box it's in an empty context, so there's no surroundings around this box. Now we will sculpt this box into a building. Actually, we want to create a building that's quite similar to the other one here, to this west building. It's going to be a similar shape. So we'll do this using direct modeling. The first thing I'm going to do is I'm going to rotate some of these faces. So as I said earlier, when I'm modeling, I usually have my face detection on, so I will leave it like this. And I want to rotate this face around this axis. So what I'm going to do is I'm going to highlight this face, and in the quad under the Model tab, there's this Rotate tool. If I click this tool, automatically a yellow widget appears. It basically shows you the direction and the axis of rotation. So I want to rotate this face around this axis here. So I move my cursor close to this axis until the yellow widget snaps around this axis. I left click, and now I can rotate my face around this axis. You see when I move my cursor, you get already a preview of where it will be rotated. And in this case, I want to rotate it around, let's say 10 degrees. I'm going to do the same for two other faces, the top face around this axis here. And then finally this face here around, again, the bottom axis. Around 15 degrees this time. So we should end up with a shape like this. Now, what we want to do is we want to create sort of kind of a column here, and the rest of this, there should be kind of a clipping in the building, like a hole. There's, again, 100 ways to model this, but actually in this case, I'm going to use this predefined grid here. The method I'm going to use now is kind of convoluted, and normally you wouldn't use this method, but actually it's one of the easiest to learn in this case, so I will just use this one. What I'm going to do is I'm going to enable my face detection. Oh, sorry, my boundary detection. And you see now, because there is a grid on top of this bottom face of this building, when I move my cursor inside one of those grid cells, the boundary is detected within this grid cell. The boundary on top of this solid face. So if I hover over this boundary and in the quad, click, for instance, push pull, you see I can push pull a hole in this solid with this shape. So like this. Actually, this is not what I want, so I will undo. I will Control Z. I'm going to push pull cells of this grid simultaneously. So I'm going to select them one by one. It's kind of annoying that boundary detection doesn't work with window selections. That actually there's a good reason for that. But so I want to select this pattern of grid cells, and then right click to open the quad. I'm going to open the push pull command, move my cursor upward, and you will see this shape being push pulled out of the solid. And I will go for a distance of 5,500 millimeters upwards. So we get this basic shape here. Okay. Now, if I create a section through my drawing, so there's a section tool here in the Home tab of the ribbon. I want to create a vertical section for my building. So I'm going to click a side face of the building to choose my direction of the section. So left click once, and then left click a second time for the location of the section. If I click here, you can see actually my building is not hollow, it's just a massive solid. We want to make this a hollow solid because obviously it's a building, we want to have space inside the building or the solid, so we want to have this hollow solid. I'm going to use the shell tool for this. Shell can be found in the modeling tab of the ribbon. There's the shell tool. Actually, shell is a sub-option of the body edit tool, just FYI. I'll click shell. And the command line gives me some feedback about what I need to do. So I have to select my 3D solid and I want a shell. I can remove faces. In this case, I don't want to remove any faces, so I'll just press enter. I can choose a distance for the shell offset. In this case, I want to have a thickness of 300 millimeters. So I type in 300 and press enter. And I can press enter twice to exit the shell command. Now you see my solid is hollow, and it has a thickness of 300 millimeters everywhere. But actually, this is still one solid. It's one continuous solid. But in a BIM workflow, we basically want to have all of our entities separate. So for instance, we want to have a wall separated from the floor slab, separated from the roof, several walls separated from each other. So instead of having one solid, we want to have all different solids. Again, there's different ways to split up this solid into separate solids. The easiest way to do it is using the BIM split tool. So I want to highlight my solid, again the solid, not just the face, so I can either turn off my face detection or I can hold down Control, and so until the solid is highlighted in blue, and I'll left click to select the solid. If I now right click to open the quad, under model there is a tool called split. Now split will basically make some assumptions about your solid. You can split any kind of solid, but it will only work on certain types. So when I click split, it will make an assumption about where to split the object into several or separate solids. You can see in some cases it's done pretty well. So this is one wall, this is one wall. These are all separate solids. But there are some cases where maybe we want to have a different situation. For instance, here I can see split up these two objects, but actually I want to have this as one continuous wall. So I'm just going to select both of them, again holding down Control to have my solid detection mode, and under model I can click union. So the union will union two separate solids into one solid. I will do the same for the other side here. Actually, I can also just click union in the ribbon. So again, in the modeling tab of the ribbon, click union and then click my two solids that I want to union and press enter. But now actually, because of this strange split action and the union, we now see that there's a non-continuous connection between this wall and this wall. So there's kind of a split here. We can solve this later or now. I will just quickly solve it now, just to make our lives a bit easier. The easiest way to do it is, actually I'm going to hover my cursor around here. I'm going to press tab once, twice, 3 times, until I highlight this back face of this solid here. And I'm going to use push-pull and push-pull it all the way until here. So now the connection is cleaner. You see, actually there's kind of still a little artifact of this operation. It's an extra edge that we don't need, so I can hold down Control to select the edge and delete it. I'll do the same on this side here. Push-pull. And I can delete the edge. Actually, another way to delete this edge is to use simplify. By the way, this is also something I should mention. There's 3 tools here under Model Integrity in the Modeling tab of the ribbon. That's Audit, Simplify, and Interfere. I recommend you to use these tools from time to time on your model. Basically, Audit will check your solids if there are any strange things going on under the hood. So sometimes a solid can have some strange things in the definition of the solid, which will make your model more complex or more slow to work with. And Audit will automatically check and fix these problems. Simplify will basically remove obsolete edges or faces or whatever. For instance, in this solid here, actually, there is this extra edge that's not necessary because these 2 faces are perfectly parallel and coplanar. So this little edge is unnecessary. So what Simplify will do is it will remove this edge automatically. I can just select the entire solid to simplify and press enter. And now this edge is gone. And interfere is basically a very basic clash detection. So you can quickly check if you are modeling and you see that maybe there's some problem. There's 2 objects clashing. You can use interfere to check where those clashes are and then solve it manually. So I always recommend using these tools, especially if you're new to modeling, because there's plenty of things that can go wrong. To use these tools from time to time. Okay, I'm going to temporarily hide this side face, this side solid here, this wall. So under Select, there's the Hide Entities tools. You can click it. Now I can see inside my building. Alternatively, you can just make a vertical section again, but in this case, I'll just use the Hide tool. And I can see here also the split tool made too many splits actually. We want to have these 4 solids union, so I'm going to union and click this solid, this, and press enter. So now this is one solid. And actually what I also want to have is, I don't want to have this hole in my floor slab. I want to have this as a continuous floor slab. So we have kind of a ceiling in this room. Easiest way to do this is I can highlight one of those inner faces here. And then there's a tool called Connect with Nearest. Basically it will shoot this face to the nearest faces it finds. So click Connect with Nearest. And the hole is filled. I can use the same technique. Let's say I want to have this wall to go all the way up here. So easiest way to do this is first I can change my connection here. So there's kind of an L connection between this floor slab and this wall. There's a tool called L Connect in the ribbon. If I click this L Connect tool, I can choose my 2 solids, so not the faces but the solids. So I can hold down Control for the solids. And automatically you should see here appear on the bottom side of your screen kind of a control widget, which means if I press Control, I can change the setup of this connection. So default is miter connection, but there's also two kinds of butted connections. So I can cycle through it using Control, and once I have the one I need, in this case it's on this one here, I can press Enter and it will be applied. And now again I can use this Connect with Nearest tool to shoot this wall all the way up to the ceiling. So I can highlight this face and from the quad click Connect with Nearest. Alright. Now I can use the BIM copy tool to copy some floor slabs and walls. So again, in the modeling tab of the ribbon, there's a BIM copy tool. BIM copy can be kind of a confusing name, but it's only useful for floor slabs and walls and planar objects basically. I'll click BIM copy to show you what it does. So I can just click a face, also a boundary, a face of this floor slab for instance, click it and press enter. And automatically it will copy this floor slab perpendicular to this face. And you can enter a distance. So let's say I choose 4,000 millimeters in between the faces. And you see again this control widget appear, which means if I press Control, in this case it's actually a repeat copy mode. So if I press Control once, you see I'm in a repeat mode, so I can repeat as many floor slabs as I want. In this case I want to have just one extra, so I left click, and I can press enter to exit the command. So it basically copied these floor slabs upwards. Now you see that these 2 upper floor slabs are not connected with my wall yet, so again I can use Connect with Nearest to connect it automatically. As I said, this BIM copy tool that doesn't only work on faces, it also works on boundaries. So if your boundary detection is toggled on, if I would now hover over my cursor over here, you see actually I don't have this entire face, I just have the boundary between these 2 floor slabs. And you will see in the quad also the BIM copy tool appear. So I can BIM copy this section of the wall perpendicular to it, so like this for instance. So especially useful to copy sections of walls in a perpendicular situation. Now actually I've been talking about walls all this time, but technically they're not walls yet. So if I would select one of these solids here, this one for instance, and open the properties panel, it's just a solid. There's just some CAD properties, but there's no information about classification type, about materials, whatever. That's something we can do later. So one of the later sections of this training is going to explain things like classifications, BIMify. But I just wanted to mention that even though you model using dumb tools, you can still apply information later to your model. Okay, so we've seen some basic direct modeling tools. The upside of using these tools is that you can basically make whatever you want. You can make any kind of shape. You can make very complex things. The downside is that it can take quite a lot of time. It can be quite tedious to create buildings from scratch using just push-pull operations. That's why we also developed some tools like QuickDraw or the stair tool, which really help you create simple layouts of buildings in no time, basically. Downside of that, of this QuickDraw tool, for instance, is that you can only use it for rectilinear layouts, layouts that are aligned with your current user coordinate system, UCS. But I'll give you an example. So if we open, sorry, that's the new drawing. If we open the office building.dwg, you will see there's actually two 2D layouts in the drawing currently. Actually, I'm going to turn off my perspective mode for a second. So actually, these are just two simple 2D layouts. This layout here is actually perfect for QuickDraw. So QuickDraw is basically, I'll maybe just quickly explain it apart from the layout here. If I open QuickDraw, you will see a special cursor appear, and it basically shows you the room that you're going to create and the walls around it. So if I just click somewhere, if I would now left click, you will see that there's actually 4 walls and this simple room in between. I can also make other shapes, like for instance I can turn it into an L shape like this. And it's actually a 3D object. The default values for wall thickness, slab thickness, floor-to-floor height and things like this are saved in your settings. You can change these at any time, of course. Okay, one of the things of QuickDraw is that so it will snap to existing objects, whether it be 2D or 3D. For instance, here we just have some lines that happen to be close to each other, but it's recognized by QuickDraw. So if I move my cursor close to these lines, you will see it snaps to it. And if I click it left click like this and snap to these walls here or these lines here, you will see a building being created. So what I'm doing here basically is I'm going from the inside to the outside, and you will see part of this wall is turned red. This means that this part of the wall will be removed because it will create an L shape out of this simple rectangle shape. You'll also notice that the thickness of the cursor adapts to your environment. So for instance, if I move close to these walls here, you see that the thickness of the cursor changes, it becomes thinner. And also notice if I draw from the inside outward, you will always create rooms within the existing building or room. So this means I can move my cursor out of the building like this, but I will still only create the inner walls. Same goes for here. I can just click anywhere around here. And voila. You also notice that when using QuickDraw, a little plus icon appears next to your building. What this means is it gives you options to copy floors or create a roof slab. So the 3 options are fully copy the top floor, copy the slab and outer walls of the top floor, so the inner walls will not be copied with it, or create a roof slab. I'll do this. I'll copy this floor a couple of times, so let's say 4 times, and then create a roof slab. And in no time, we have a simple building. Now, one of the things that distinguishes QuickDraw from tools like using extrude or push-pull, like we did in the previous exercise, is that it already assigns some basic BIM information to your object. So for instance, if I would select this object here, it's not just a solid, it's actually a wall. If I would go to the properties, you see it's a solid, but it has a wall type property. It's part of a building, part of a floor. We see some quantities being calculated as well. So already some basic information is assigned to the objects that you make with QuickDraw, which can be useful at times. Okay, let's say I make a vertical section through my building here. Oops. Let's say we now want to create a staircase in between two floors. I can actually very easily do so using the stair tool. So we have a stair tool here in the modeling tab of the ribbon, or in the home tab as well. This stair tool creates a very basic layout of a stair, but it's actually very intuitive to use. So again, when I click the stair tool, you will see a special cursor appear. It's very similar to the one used with QuickDraw. Thing about this cursor is that it will snap to existing floor slabs. Let's say if I move over here, it snaps to this floor slab, this one, and it will snap to existing walls around it. So let's say I move my cursor here, it snaps to this wall. You can also, as you can see with the control tip down below, is that you can press control or tap control a few times to change the direction of your stair. In this case, I want to create a staircase that goes along this wall. So I left click once I have my location here. And you will see as soon as I move my cursor towards another slab, you will see a preview of the staircase appear. And depending on where your cursor is, you will have single flight staircase, or a L-shaped, or even a U-shaped. So in this case, I will snap to this wall. Actually, before I do it, you will notice at some point, like for instance here, my staircase has turned slightly darker blue. That is because the staircase also has some preset settings, such as the optimal step-to-step height, or the optimal length of a step. And when this preview finds a location of the staircase, or a configuration of the staircase that matches these default settings perfectly, it will snap to it, like is the case here. And it will turn slightly darker blue. Now in this case, when I snap to the wall, it turns lighter blue again. That's because there is, in this case, no perfect configuration that snaps to the wall and matches those default settings. Then you can just left click to place the staircase. Automatically, also a hole is created in the floor slab, also based on a room or a headroom setting in the settings panel of the staircase tool. You can still change these holes. Let's say, for instance, here. Let me just quickly go to settings to show you what the default settings for the stair are. So stair width, preferred tread length, riser height, headroom, step thickness, nosing, all of these things can be set before starting to model your staircase. You can also still change them afterwards. So let's say you have a staircase like this. I can still go to the settings and change, for instance, the width or the step thickness. Let's say this step thickness to 100 millimeters. All right. Now, this Quick Draw tool is very useful when you have very simple rectilinear layouts. But let's say we have a layout like this. First of all, it's not along my current UCS. There's walls that are not perpendicular. There's curved walls. So in this case, I can't really use Quick Draw. It won't work. It won't work properly, at least. So you can still use this layout to create your building. Actually, what I'm going to do in this case, I'm going to turn on my boundary detection and search for the boundary in between these two lines here. And I can use the extrude tool to create a solid. Actually, I'm also going to move these bottom faces down by 250 millimeters as well. So for this, I will use push-pull. So we can easily create the floor slab later. The reason I did this is because now you see under this line here at the bottom edge of my my wall, now there's a boundary because this line makes the boundary between the bottom edge of the wall and this line. So I can use this boundary again to create new geometry. For instance, I can create a new floor slab by using solid extrude. I will extrude it to somewhere, let's say over here. Now I can use, again, the connect with nearest tool like before to create the floor slab. Now it nicely fits around this round edge here as well. Now actually, as I mentioned before, I'll turn on my perspective mode. I prefer perspective. As I mentioned before, we want to have all our walls and slabs and things like this as separate objects. So again, I will use split to split these walls because this actually is one solid right now. I will use split to split this solid, so like this. And you see now, this is a separate wall, this is a separate wall. But in this case, split didn't really find a solution for this curved wall. So we're going to have to split this manually. The easiest way to do this, according to me, is I will so hold down Control to highlight the solid of this wall. And in the Model tab, there's two slice tools. This one is slice by object, and this one is multi-slice. In this case, multi-slice is the easy one to use. So the one with two blue blocks here. I will click it, and it first asks you for a planar slicing face or surface. So basically what I want to do is I want to slice my wall around here in this direction. So I can use any face that has this direction. So for instance, this face here, as soon as I left click this, you will see actually this slicing plane appear. I can click anywhere to slice it along, so where the blue slicing plane cuts through my solid, or I can snap to existing points. Let's say, for instance, I can snap to here, press enter, and I will see that this object is sliced around here. Now I want to do still the same on the other side here. So again, use multi-slice, choose this face, and slice around here. And just like this, we have sliced our objects into different pieces. Now I want to still create my inner wall, so I again will go into the boundary, use solid extrude, and extrude until the same height as these walls here. And again use split to split the objects into separate objects. So that's one example of using a 2D layout without using Quick Draw and still creating a 3D model out of it. Now I can easily copy them if I want to. like this, for instance. Okay, so these were some basic modeling techniques. Remember, I've been using quick draw, I've been using things like push, pull, extrude, split, and slice. You can use all of these methods in a combined way, so you can use hybrid methods between quick draw and push, pull, for instance. It's all up to you, basically. It's up to you to find the easiest way or the most useful way to you to create certain geometry. Once we have this geometry, we can add more information to it. We can classify it according to the IFC classifications. We can add custom properties to it, things like this, but that's for a later course. I think that's it for now. Thank you for watching, and good luck.